Okay, for months and months now I've been trying to figure out what it is in that stupid little toy there called the Lucky Waving Cat that makes that do that on the little tiny solar cell. And you can see I've got that mechanism that's from that cat toy driving this pulse motor on ambient indoor light. And it's been driving me nuts because I couldn't figure out the circuit, and so I went back to it to try to work on it some more. And I did come up with a circuit here that kind of does the same thing, and it's very similar to one of the SolarBotics circuits, if not the same thing. But I found that it was an LED light driver circuit to make an LED go, and I started fiddling around with it. It's one of these complementary transistor circuits. It uses a PNP and an NPN transistor, and sets up an oscillation between a great big capacitor and a smaller capacitor, and sets up a dynamic that will get this rotor moving back and forth until finally it starts going around and around. And anyway, I just call this the auto start pulse circuit. Didn't know what else to call it. And like I say, it's similar to the SolarBotics circuits. If you go to SolarBotics, they have circuits like this that pulse their little bug-bot circuits. So anyway, I've got this hooked up to this copper semiconductor battery, which I've been working a lot with, and I'm having a lot of trouble with it. Black deposit forms on this, and it stops, and basically disconnects the circuit. So I've got to figure out why it's doing that. I may have to change materials. This is a marine zinc. I may have to end up using magnesium, but this thing will also run on that solar cell. But to get this started here, I wanted to use this battery here. It's about a 1-volt scenario, so I'll show you how this works. This will start charging up. You'll see this LED blink here. And you see the rotor starting to move, and it's going to knock that thing around and back and forth until finally it gets into some sort of a cadence or a rhythm. And this could take minutes before it actually starts up and starts spinning, but you can see it got going the first time. Let me stop this. I'll show it to you again. And it'll knock it. See it knock it right there, and it'll knock it again. And that's this circuit firing, and well, you can't even hardly see that LED go, but this is an LED driver circuit that I've modified with a great big cap and then another cap to make this auto start function. Let me show it to you one more time. And this just pulses at the same rate, but because of the imperfections in the rotor and the dynamic of the magnetic field of the earth and all that, this will get this thing to move. And off it goes. And sometimes it starts one direction, sometimes it starts the other direction. It just all depends on the dynamic of how it pushes that rotor around. But once it gets turning at a certain RPM, then this thing just keeps right on going. But it can take 3, 4, 5 minutes before this settles down to what it wants to do. See, it just stopped there. Now it's going to push it the other way. Maybe not. Maybe the same way. But this finally gets going, and then it's going just like that over there. It's the same dynamic. And anyway, that's my latest attempt at this self-starting circuit that runs on very, very low power. Now this runs at about 1 or 2 milliamps, and that's putting out about a volt right there. So that's the kind of power that I have to go after to make this thing work. If I up the power on this, this locks up and won't work, and I don't know the dynamic of that at all. So anyway, that's this circuit here. This is called my auto start pulse circuit, and I'm lid motor, and this is 5th day of April 2011. Thanks for watching.